Hello all, today we are starting with rotations. This is the next one of our transformations and let's get to it. Have a little do now for us today. So everyone take a second, again, pause the video, take a few seconds and try these. Obviously with these assessments essentially being take-home assessments, you don't have to necessarily like memorize the rules, but you do just want to be comfortable with applying them, to make sure you know exactly what they are and you don't have any issues with applying it for any particular point. So pause the video, see what you can do here. So for the first one, it's a reflection on the x-axis. The x-axis is going to be, it's going to be x negative y for the rule. So my new point would be 4, 7. For the next point, it's the y-axis. So the y-axis, it's negative xy. The y changes, and that's going to be 9, 3. For C, it's over y equals x. That's the one where they switch positions, and that's going to end up being negative 5 to negative 2. After the translation, this would be negative 12 and 0. And the last one is asking you what's the vector for this graph. So for this graph, remember, again, you got to pay attention to the letters. So we're going from red to blue because this is the prime. So I'm just going to look at the A point. So it's 5 to the left and 3 up. So I'm going to write that as negative 5, 3. All right, so that was just a little refresher. And let's start with the rotations today. So for the rotations, again, I just want to get some of the basics about rotations out. A rotation is a turn about a given point. So if this is our coordinate plane, we're taking a figure, let's say it's this arrow, and we're just turning it. Most of the rotations that we're going to do are going to be about the origin. So we're going to take it and turn it about the origin here. Excuse me. Standard direction, this is one thing that is very important. Standard direction for any of our rotations is going to be counterclockwise. If you're thinking about what the traditional clock looks like, we know that it goes, sorry, let me give you a minute hand too. We know that it goes in this direction, clockwise. Standard direction for any of our rotations is going to be counterclockwise. So if it doesn't say, if you just see like 25 degrees, that means that our default is to go counterclockwise against the clock. So keep that in mind. Again, it's either going to be clockwise or counterclockwise. If it doesn't say anything, it's counter. If it says, then it's, clockwise. Again, these, just like the reflections and the translations, are isometric, meaning that the preimage and the image are congruent. There's no size change, etc. And then the last thing, well, actually I have one more thing here, but orientation is preserved. Sometimes people think with rotations that orientation is reversed, but it is preserved. If you think about it, if this was our coordinate plane and this is our letter, let's say T here, and you're rotating it about the origin, it's not going to be this way. Let me not do it on this weird angle. Let me just do it straight up. Be more obvious. So here's my T. If I'm going this way, that would be 90 degrees. And this would obviously be clockwise, so it's going with the clock. It would look like this. Again, some people might think it's reversing orientation, because here it would now be upside down, but it's not. It's just literally taking the same thing and turning it. So it's not quite the same as a reflection, which would be over the line and actually reverse orientation. Next, and then it's prime notation. Just note that everything will be in prime notation. All right, so I just have a few just quick basic little questions about rotations. I want you guys to give a try. Again, you can pause the video at this point, give them a look. So for the first one here, I'm asking you how many degrees is the rotation. Now your question should be which direction, and I didn't write that on purpose. I just wanted to see like if you guys are paying attention here. So for this, if I don't indicate, I would always have to indicate which direction, because I could either have gone this way, and I didn't even tell you which one was the original. Let's say the blue was the original for this. So I could go this way, or I could be going all the way around this way. So that has to be something that's established, clockwise or counterclockwise when you're doing these things. So in this case, this would be, I'm going to say, let's say counterclockwise, since that's our default. So if I'm talking about counterclockwise, that means I'm going from here all the way around this way. This is 90 degrees. Again, if you're thinking of basically going one coordinate plane, that's 90 degrees. This is another 90. This is another 90. So it would be 270 degrees. This next one actually to rotate 180. If you rotated this 180, give or take my drawing skills with the stylus and period, it looks like a mushroom. It would look something like this. Excuse me. And when it's 180, you do not need a direction. 180 is the same whether I went this way or this way. So 180 will not have a clockwise or counterclockwise indication. The next thing we have here is to rotate 90 degrees clockwise. So it's going to go from here. Clockwise is this way. So we should expect it to go from this quadrant basically to the next quadrant. That would be 90 degrees. And it should be facing this way. Something like that for the 90 degrees clockwise. Rotating 90 degrees, again, nothing is indicated here, so that means it's counterclockwise. If it's not indicated, it's counterclockwise. So I'm going to go this way, and essentially it would look something like that. And then 270 clockwise would mean I went 90, 180, 270. So I'm going to be here. And it's actually going to look the same. And this would have been, just so you can see the progression, this would have been 90 degrees. This would have been 180. And then this would be the 270. So just note that when it's 90 degrees clockwise and when it's 270 degrees 90 degrees counterclockwise and 270 degrees clockwise, these end up in the same spot. That's actually an important concept, and we'll cover that on the next slide or so. All right, so when we are rotating in the coordinate plane, we have rules just like with the reflections, and the rules are going to exist when we are rotating about the origin. So it'll have to specifically say rotate 180 degrees about the origin. It'll have to say that before you can apply the specific rule. So if it's a rotation of 90 degrees about the origin, what that means, this diagram here gives you a good idea of what this looks like, is that this is my point B, and this is my point B, and this is my point B prime. So again, 90 degrees without saying anything, that means it's counterclockwise. That's the default. So we're going from B this way because we're going counterclockwise. So what this is saying is that since we're doing it from the origin, is that from B to where our B prime is, that's going to be a 90-degree angle. That's what the 90-degree rotation is doing. The same thing would happen if we looked at C. From C, let's go a straight line here, but from C to C prime, that's going to be a 90-degree angle. So this is what the rotation is doing. And the rule is going to be, as you can see here, that they switch places, and the new y, the new x, or the original y, is going to change signs. So I have a quick example here before we actually do one in the coordinate plane. So it's saying, what is the image of A after a 90-degree rotation? So again, if it doesn't say any direction, it's counterclockwise. That's the default. So just want to practice this. First thing I normally do is just do the switch. There is a switch. So let's do the switch first, and then we'll acknowledge the sign. So I'm going to switch. So I'm going to have -7, and then I'm going to have 4. That's just the switch. Now, this one has to change sign. That's, again, the negative doesn't mean it's negative. It means sign change. So just remember, it doesn't have to be negative. So that means that now this is going to become a +7. Again, you don't obviously need a sign, so you could just have it be 7, 4. All right, so let's look at our first example here. when it comes to these rotations. So for the first one here, I think the other ones I have the graph already done, but for this one I left it blank. We want to follow the same steps we did before. So graph the original. We always want both on the graph. So it's 3, -5. That's our A. B is -1, 2. And C is 0, 5. All right, so let's see exactly how bad my lines connect. Oops, don't want to do that. Holding it still for too long. Trying to get it straight. Ooh. That's really bad. Let me try that again. Oh, I have gotten a little better with the stylus over this time at home, but still ultimately. So okay, this. But anyway, that is my triangle. So now I'm going to just go for the rule. Again, just like with the reflections, I would just apply the rule first. Don't try to, do anything without it. So the rule, just stated, is going to be -yx. So at first, again, I'm just going to switch them. So for A, I'm going to switch. It's going to be -5, 3. Then I'm just going to actually switch them all really quickly. And then 2, -1. And then it's 5, 0. So again, I just did the switch. Now I'm going to go back and change the signs of all of my new x's. So here I'm going to have a +5, a negative, and a negative. Switch, the new x changes sign. And now I need to plot my new points. So again, you should have a thought process as you're doing these as to where it should end up. So again, if you end up with something over here, obviously that doesn't look like this triangle, but if you end up with something over here, that does not look like something that was rotated 90 degrees counterclockwise. If it's here and it's 90 degrees counterclockwise, you know it should be going in this direction. So again, keep that in mind as you're doing it. If it doesn't look right, you can try to figure out what your mistake is. So I'm going to plot my new points. My new points are 5, 3. And that's A prime. -2, -1. About to go up. And that's B prime. And then C prime is -5, 0. So this is our new triangle. And I'm going to shade it in. And basically everything is just going one quadrant back. So this is not on a quadrant, it's on the y-axis, but it's there. This went from quadrant, remember our quadrants are 1, 2, 3, 4. This is going from quadrant 2 to quadrant 3. This is going from quadrant 4 to quadrant 1. Everything's moving like one quadrant around. All right, I have one more example here. All right, so you guys give this one a try on your own. At least, again, try to do the coordinates. If you don't take the time to graph it, all right, even though you should practice a few graphs. All right. So this is the resulting graph. I noticed over here I still had A, B, and C, so sorry about that. So just switch these to like X prime, Y prime, and Z prime in your notes or whatever, guys. My bad about that. It'll probably be like that on every other slide too. I copied and pasted, but I didn't change the letters. Or that was the first one. Let's go to the next slide. Oh, I'm sorry. And there is one other thing I wanted to note. On the first slide, I mentioned the connection between the 90 and the 270. Just so you know, there are only 3 rules. It's going to be 90 degrees counterclockwise, 180 degrees, and then it's 90 degrees clockwise. But 270 is the same. So if we look at what we have here, this is our 90 degrees counterclockwise rotation. But if we went 270, they would end, I'm sorry, 270 clockwise, they would end up in the same place. So you should also write this rule down as not only your 90 degrees counterclockwise rule, but this is also the rule if you're asked to rotate 270 degrees clockwise. They will end up in the same spot. So there's 3 rules, but again, 2 of them kind of work both ways. All right, next slide. All right, so for this slide, we're rotating 180 degrees. Now, when it's 180 degrees, it's a little bit easier for the rule. You don't have to flip any of, you don't have to, switch the two letters. All you're going to do is change the sign. So it's just a sign change only. Now, when it comes to the 180, again, as I said, like on the earlier slide, it doesn't matter whether you're going clockwise or counterclockwise. It's going to result in the same figure or the same location. So you won't see a direction when it says 180. And again, this is when it's about the origin. And over here is a little example of what's going to happen. Again, we would have a straight angle. Why am I going over that way? A straight angle, basically, or 180 degrees, taking you from B to your new B prime. And here's a quick example before we look at a graph. What is the image of A under 180 degree rotation? So again, here we're just simply changing signs, no switching, nothing like that. So our answer for this one is going to be, if we're just having a sign change, it's going to be 2, 5. That would be our A prime after 180 degree rotation. All right, so let's look at our first example here. Instead of wasting the time, like keep graphing it, I already have the original graph here. I'm using the same two triangles for each one of the rotations here. So again, apply the rule first. You want to graph the original, apply the rule, and then plot the new points. So here we go. All we're going to do is change the signs, negative x, negative y. And again, the minus means sign change, not negative. Keep that in mind the whole time. So originally it was for A, 3, negative 5. So it's now going to be negative 3, positive 5. For B prime, it's going to be 1, negative 2. And for C prime, it's 0, negative 5. And just like on, I think it was the reflections, please do not put 0 as a positive or negative. It should just be 0. 0 has no sign. So, and let's plot these new points and see if this looks right. Again, if it's 180, it should essentially be like facing upside down to some degree. All right, so let's plot these points. Negative 3, 5. That's our A prime. B prime is 1, negative 2. Sorry, holding it in place too long. Brings up that screen. And then for C, it's 0, negative 5. Ooh, try to do it quick. C prime. And let's connect these. And shade it in. And that's pretty much how it should look, just like that. All right, I have one more example here. So everyone, take a minute, try to do this one, rotate and get 180 degrees. Okay, so here's the answer for the last one. Hopefully you guys were successful. Again, practice a few of the graphs, but at least you should be practicing listing out the new coordinates, applying the rule. All right, let's move on. And our last rule is going to be a rotation of 90 degrees clockwise. So if you look here in the little sketch diagram they have there that I put up here for you guys, for this one, they're actually expressing it as a rotation of, you see that it's going around like that. They're expressing it as the 270 counterclockwise rotation. Excuse me. Which is also what this rule is good for. So you can also put that 270 counterclockwise as well. So again, when you write down these 90 degrees, it should be, also thinking that this could be considered 270 and 90 is vice versa. All right, and let's look at the first example I have here before we look at the graph. So for this one, when it's 90 degrees clockwise, again, there's a change, just like there was, a switch in the two letters, just like there was for 90 degrees counterclockwise. But when we change this time, the sign of the X is changing. So switch places, and then we change the sign of the new X. I'm sorry, the new Y with the old X, however you want to think of it. So let's look at this. So let's switch first. Again, I like to switch first. So I'm going to say my A prime. If I switch first, I'm going to have 3, -9. That's just doing the switch. Now I have to change the sign. So this is now going to be a +9 here. Again, no sign necessary at all. So my answer would be 3, 9 for A prime. And let's look at our first graph. Again, I'm keeping the same graph for this one as well. Already have it plotted. So let's just practice applying the rule to get the new point. So again, we're switching and we're changing our sign of the new x. So for A prime, it's going to be -5, 3. I'm just going to again switch all of them like I did before to -1 and then 5, 0. That's switching places, and now I have to do the changing of the signs. So for this, it's now going to be negative, positive. And again, 0 has no sign, so we leave that alone. And let's plot our new points. New points are going to be -5, -3. That's A prime. 2, 1 is B prime. And 5, 0 is C prime. Shape looks the same. It's where you should think it would be. Again, it's going that way. And it's only like one quadrant change. Excuse me. So then hence the 90 degrees. All right, try this example on your own, and then we'll unpause it. All right, so this should be what your last problem looks like on this slide. So let's go ahead to the next one. Okay, so everything we've done so far has been about the origin. The next two examples that we're going to do are not going to be about the origin. So it's not, I mean, I've said this, I hope everyone at this point would have known what the origin is. I never really addressed it. But the origin is that, center point 0, 0. I'm sorry. I should have restated that. But it's that center point 0, 0. So everything we've been doing so far, according to all these other rules, is rotating around the origin. Now we're going to look at a few rotations where it's not around the origin. Now, this isn't necessarily an incredibly difficult process, but it does involve quite a few steps, as you can see, because I wrote out the steps here, and there's quite a few of them. What you want to do first is plot the original points, which is done. As you can see, I already have it here. Again, we're doing the same triangle. The second thing you want to do, step 2, is to, let me just write steps here. Second thing you want to do is plot the point that you're rotating around. So if we read here in the problem, it says rotate triangle ABC 90 degrees. So again, it says 90 degrees with no direction. So that means I'm going counterclockwise. So keep that in mind. Let me just write the rule so we get that over with. 90 degrees counterclockwise is going to be -y x, just so we don't forget. So anyway, so the second thing we need to do is to plot plot the point you're rotating around. So the point I'm going to rotate around is this point, -3, 1. So -3, +1, that's the point I'm plotting. So that's what I'm going to now be rotating around, that point, not the origin, which is here. So erase, erase. All right. So what I'm going to do next is to create a new origin with the point of rotation. What that means for step 3 is that I'm going to just draw a new origin here, kind of like a new axis, basically. I should probably say that word instead of origin. But you're basically going to make like a new coordinate plane using this point as the origin. Hope that makes sense. Because that's the thing we're going to rotate around, that point. So, step 4 says to assign new coordinate values using the new origin. So, again, not incredibly difficult, but they can be a little tricky. Make sure you're following each step. So what step 4 means is that using this new fake origin here, we'll call this fake origin, we want to now give these values, A, B, and C, coordinates. So from my fake origin, that means this is 0, 0, right here, 0, 0. So that means that B would be -2. Actually, let me go A first. Actually, let me do B first because it might be clearer because it's closer. So for B would be +2. I don't know why I'm saying negative. So from here, I'm going 2 to the right. So that's why it's a +2. And then I'm going up 1. So from my fake origin, I need to assign A, B, and C new coordinates. Okay? So from here, 2 to the right, 1 up. So that means that B is 2, 1. C, again, from my fake origin. So don't go here to the real origin and find the coordinates. That's wrong. You want to do it from the fake one. So from this fake one, now I'm going to continue. I only need the coordinates of C. So C is going to be from here, 0, 0, 1, 2, 3 to the right. So I'm going to put 3 here. And then after my 3 to the right, I'm going 1, 2, 3, 4. So C is 3, 4. And then lastly for A, that one's the farthest away, so I'm doing that one last. I'm going 1, 2, 3, 4, 5, 6 units to the right. So I'll put that. And then I'm going 1, 2, 3, 4, 5, 6 units down. So my A has the coordinates of 6, 6. Again, hopefully that made sense. You don't move the points, they stay where they were, but you changed from these original real values to fake values based on this being the true origin, even though it isn't. All right, next step, step 5. Step 5 says to apply the rotation rule to the new values. So here's the rotation rule. Again, I rewrote that. So I'll just rewrite it. -yx. I need to apply this rule to my fake values. Again, if I do it to the original values, that's just going to give me the rotation as though I did it about the real origin, which is not what I want to do. So now let's do this. We switch places. So again, I'm going to switch, and that's going to be same 6, 6. I'm just switching first. Switch, switch. So that's everything switched. Now, again, I need to change this sign. So these are all going to be negatives in the x places. Then I can go ahead and plot. I should have written that down. I'm sorry. I should have like a step 6 there, plot the points. And then there should be 7. Sorry, I didn't realize I didn't put that. All right, so then now I'm going to plot these new points. And that'll basically give me my rotation. So I'm going to go ahead and plot the points. My points are -6, 6. And again, key thing, -6, 6. We're plotting these points from the fake origin. So don't go back to 0, 0 and say -6, 6. That's going to be incorrect. We need to plot these from the point of rotation or our fake origin. So let's do that. So let's begin. -6, so from here, 1, 2, 3, 4, 5, 6 to the left, 6 up. And that is our point A. We can label it A prime at this point, but we'll just leave it alone for a second. That's A. My new B is going to be -1, 2. So again, from my fake origin, -1 to 1 means 1 to the left, and then 2 up. And that's going to be my B prime. And then my C prime is going to be -4. 1, 2, 3, 4, +3. That does not look right. What did I do wrong? -6, 6. Hold on. Oh. Oh, I did switch it. Hold on. Just trying to make sure I did this right. Did I switch them? Yes, I did. So -1. That was positive. 2, 1. Okay. And then C was 3, 4. So that looks right. Trying to see why this doesn't look right, because this C is obviously not in the, I'm sorry, this C is obviously not in the right place. Like it belongs someplace down here to make this work out. So let me figure out which one I messed up on. So it has to be, I guess the C is the one that looks wrong. So let me look at that one. So from my original point, 1, 2, 3, 1, 2, 3, 4, 3, 4, that looks good. That looks good. Maybe my B is wrong. To the right up 1. So -1. Okay. Oh, sorry. I just realized where I messed up. My A is the thing that's wrong. Here we go. So the C looks okay. Messing up on the wrong one. For my A, it was a negative. Sorry. I'm looking at the focus on the wrong points. So A wasn't 6, 6. It was 6, -6. My bad. So when I switched them, it would have been. Oops. So at that point, when I switched them, it would have been positive 6, 6. So it would be 1, 2, 3, 4, 5, 6, 1, 2. Oops, it is. It's a little sloppy, but that's what it should look like. Sorry about that. All right. So even though this is a rotation, you're still not done. If you leave it right now with these values, this is what a lot of students will do wrong. Unlike well, you guys aren't having any testing this year, but unlike the park and things like that, this would be like where some students will leave it and mess up. The reason this isn't the final answer is because this isn't the real coordinates of A. It's not 6, 6. If we did 6, 6, that's this point right here. So the last thing you're going to need to do to finish this up is to assign true point values, like the actual true point values for A prime, B prime, and C prime. And those actual point values would be you going back to the real origin. So I know it's a lot. Like I said, it's not necessarily difficult. It's just time consuming these. So you go back to the real origin and you figure out what the coordinates are. So from here, it's 1, 2, 3, then up 7 for A. B prime is from the real origin, 4 to the left and 3 up, so -4, 3. And C prime is 7 to the left and 4 up. So this would be your actual final answer. All right, so I have one more of these on the next slide. And I'm going to leave it here. Again, maybe you guys could practice with the coordinates and etc. But I guess I'll go through it because this one is a little tricky. So I'll do the second one. I was just going to leave it for you guys to do. Try to do it as fast as I can. I know we're at 30 minutes already. But for this last one, this is 180 degrees. So the direction doesn't matter. What you want to do, original points are plotted. Check for 2, plot the point you're rotating around. So for this one, you're rotating around this point. It's 3, 2. So over 3, up 2. That's what I'm rotating around. I need to create a new origin from that point. So from here, that line is crazy. Hold on, I can do a little better than that. Actually, let me use the thicker marker. So for this one, why am I shading? Why with the stars? Okay, there we go. That's still bad. That one was good. Look at that one. All right, so that's going to be my new coordinate plane or my new origin for the coordinate plane. Done. Now step 4 is to assign, I shouldn't put a check on that yet. Step 4 is to assign new coordinate values using this origin. So instead of these original values that we were given, and I did the same thing here, I copied the table from the other one, but I didn't change the values. So this is x, y, and z. My apologies. X, y, z, x, y, z. Alrighty. So we have the right points now. So next thing I'm going to do is just list the new coordinates for these values. So for x, it's now going to be here. This is my 0, 0. So 1, 2, 3, 4 to the left and 1 up. So negative 4, 1. My y is 4 to the left as well, but it's going to be 1, 2, 3, 4, 5, 6, 7 up. So negative 4, 7. And my z is 1, 2, 3, 4, 5, 6, 7 to the left. And then it was 7 up, just like the other one. So negative 7, 7. All right. So that's step 4. Done. Now, step 5 says to apply the rotation rule. So the rotation rule for 180 is negative x, negative y. No switching places. They're just changing signs. So again, we're applying the rotation rule to these fake points, so to speak, because that's what we want to rotate around this, not the original origin. So it's going to be 4, negative 1, 4, negative 7, and 7, negative 7. Those are my new values. Again, I need to add a real step 6 here. It's to plot the new points, I say fake points. And then 7 is to assign true values to the points. So I'm going to plot these fake points now. Again, I'm plotting them from the faux, we'll use that word, it sounds a little better, right? We're plotting it from the faux origin here. So it's going to be 4, negative 1, so positive 4. So from here, 1, 2, 3, 4, negative 1. And that's x. Then it's going to be 4, negative 7. 1, 2, 3, 4, 5, 6, 7. Can't hold it too long or the thing will come up. That's y. And then for z, it's 7, negative 7. So 1, 2, 3, 4, 5, 6, 7, negative 7. I'm sorry, these are primes. Let me put this on the other side so it won't be in the middle of the triangle. All right, so this is my triangle. Shade it in. Boom. All right, so that's my answer. I've completed the rotation. But again, if I leave it here and circle this multiple choice answer, these are not the actual coordinates of these points. So I need to just do one extra little step, which is to go back to the real origin, 0, 0, and determine the actual coordinates of x prime, y prime, and z prime. So x prime is going to be 7, 1, because I'm from 0 over 7 up 1. Y prime is going to be 7, negative 5. And z prime is going to be 10, negative 5. All right, that's it, guys. Sorry, this one was a little long. Do the review. I put a couple questions in a worksheet or two on Classroom.